Part 1. Fraction addition with the same denominator. A fraction can be thought of in two different ways. The first way is as one thing divided into portions. The second way is as multiple things divided into portions. We have to use both ways of thinking of fractions to understand how to add them. Consider a simple case, 2 over 3. Before we even think about adding it to something else, let's ask ourselves, what is 2 over 3? What is it really? As I said, we can think of this fraction in two ways. We can think of it as one thing cut into 3 parts, where we take 2 of the 3 parts. The other way to think of it is as 2 things cut into 3 parts each, where we take 1 part from each thing and add them together. What does this have to do with fraction addition, you ask? Well, it's fairly simple. Consider a case where the denominators are the same, as in 1 over 3 plus 1 over 3. Well, your teacher in primary school probably told you to add the numerators and use the common denominator. It's easy to explain why. Remember our circles from before? Just cut each one into 3 equal parts and take 1 piece from each. These are our 2 fractions. Simply put them together and count them. Each one is 1/3 of a circle, and there are 2, so together they equal 2/3. Notice what we did? We began by thinking of the 2 fractions as 2 different things. Then we figured out how to get from thinking of them as 2 different things to thinking of them as one thing. Remember what I said in the first video about how 1 plus 1 is the exact same thing as 2? Well, 1 over 3 plus 1 over 3 is the exact same thing as 2 over 3. Let's do another example of common denominator addition, just in case you didn't quite get it the first time. Consider 2 over 4 plus 2 over 4. To make it work, we repeat our thought process from last time. How can we go from thinking of the 2 fractions as 2 things to thinking of them as one thing? Well, take our 2 circles again. Cut each circle into fourths. We're dealing with 2 fourths here, so take 2 pieces from each circle and add them together. What do we get? Well, count the pieces. 1, 2, 3, 4 pieces. And each piece is 1/4, so we have 4 over 4. Notice that we have a whole circle, so the whole thing equals 1. Incidentally, this is why any number divided by itself is equal to 1. If you divide a circle into 8 pieces and take all 8, then put them back together, you get 1 whole circle. One more thing you have to understand is that you can have plus and minus signs in the numerator or the denominator. Remember what I said about 1 plus 1 being the exact same thing as 2? Well, that means you can take away the 2 from the 2 over 3 and replace it with 1 plus 1 and nothing changes. Remember how we add the numerators? Well, that works backwards, too. If we have 2 over 4, we can break the 2 into 1 plus 1. Then we can break that fraction apart by copying the denominator and moving the numerator. To go back to our circles, this is just reversing our thought process from before. We begin by going from thinking of the fraction as 2 fourth-sized parts of one thing to thinking of the fraction as 1 fourth-sized part of each of 2 things. Together with the notion of addition, we get the idea of breaking the fraction into pieces and putting it together again. The real jump comes from transferring this idea from the circles into mathematical notation. Let's do one more example, without the circles, just to make sure you get the notation. Take 2 over 11 plus 3 over 11 plus 5 over 11. First, notice that the denominator stays the same. Then, move the pluses and other numbers on top of the bar with the 3. Now, we just add the denominators and voila! We are left with 10 over 11.